It's time for Defending and Commending the Faith with Joe Mott, inviting the atheist, agnostic, and skeptic to examine for themselves the evidence for the Christian faith. We are all limited by what we do not know and by the things we think we know but are not true. Dr. Joe Mott earned his PhD at LSU and was a distinguished math professor at Florida State University for 38 years, helping to write 3 math textbooks and authoring over 30 research articles in math. He is now the host of this radio program, Defending and Commending the Faith. Here is Joe Mott.
At the end of the episode 52, I mentioned George's Lemaitre's solution of Einstein's field equations, and his model of the universe marked the birth of Big Bang cosmology, and consequently Lemaitre became known as the father of the Big Bang theory. This theory states that the universe is expanding from a single hot, extremely dense cosmic egg in the distant past. There was a massive explosion called the Big Bang, in what scientists now call one type of singularity, and the universe has been expanding ever since. Thus, the universe had an actual beginning, and consequently, the Big Bang theory points rather conspicuously to a theistic view of the universe. Taken together, the Big Bang theory and Einstein's general theory of relativity each provide a scientific explanation of what Christian theologians call creation ex nihilo, a Latin phrase that translates to creation out of nothing. The Apostle Paul writes in Romans 4, verse 17, God calls into being that which does not exist. Christian theology says Paul got it right. Dr. Alan Sandage, widely known as the greatest observational cosmologist in the world, after having been awarded all types of honors, including astronomy's equivalent to the Nobel Prize, announced his conversion to Christianity and stunned the scientific world in the 1980s when he disclosed that he thought the Big Bang is clearly a supernatural event that cannot be explained within the realm of physics. He declared, "It was my science that drove me to this conclusion. It was only through the supernatural that I can understand the mystery of existence." That's found in The Case for a Creator by Lee Strobel, pages 69 to 271. Let's return now to discussing the remaining points of my acronym, SURJET. I've already discussed that S stands for the second law of thermodynamics, H stands for hydrogen's abundance, and U stands for the universe's expansion. R stands for the cosmic microwave background radiation in Big Bang cosmology. This radiation is a remnant from an early stage of the universe, also known as relic radiation. There was, for a time, some evidence that didn't coincide with Lemaitre's Big Bang prediction of the expansion of the universe. In particular, the first calculations of the age of the universe, deduced from the recession of the galaxies in Big Bang theory, turned out to be less than the age of the stars and planets, deduced in other ways. But later an error was discovered in the calculation of the recession speeds that rectified that discrepancy, so this objection went away. The breakthrough happened in 1965 when Arno, Penzias, and Robert Wilson discovered the radiation whose characteristics were consistent with its being the light from the Big Bang explosion. once very intense, but then made very faint by billions of years of cosmic expansion. Very precise measurements and refined mathematical analyses showed a complex structure that is in remarkable agreement with the predictions of the Big Bang Theory. This discovery was the culmination of work initiated in the 1940s and earned Penzias and Wilson the 1978 Nobel Prize in Physics. This discovery forced the majority of astronomers to accept the Big Bang Theory. Penzias said this about the Big Bang: "The best data we have are exactly what I would have predicted had I nothing to go on but the first 5 books of Moses, the Psalms, and the Bible as a whole." G stands for galaxy formation. Billions of years ago, the universe burst into existence from the Big Bang, causing something like seeds for galaxies. The ripple effect was observed by the COBE satellite in the 1990s. Theorists posit that the universe has been expanding ever since the Big Bang, cooling enough along the way to provide suitable conditions for the formation of galaxies, galaxy clusters, stars, and planets. E stands for Einstein's theory of general relativity. It shows that the mathematical solution of the field equations supports an expanding universe that makes space, time, matter, and energy come into existence along with the beginning of the universe at the Big Bang. T stands for scientific theorems that indicate that the universe had a beginning. First, the theorem due to Arvind, Borde, Alan Guth, Alexander Velinkin, states that any universe that is on average expanding must have a beginning. Even if our universe is just a tiny bubble universe in the so-called multiverse, composed of many universes, the multiverse itself cannot be eternal in the past, but must have an absolute beginning. Velinkin is quite blunt about the theorem's implications that the beginning of our universe is now certain. He said, "It is said that an argument is what convinces reasonable men, and a proof is what it takes to convince an unreasonable man. With the proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning." Second, there is the Penrise-Hawking Singularity theorems. In Friedman's and Lemaitre's solution of the Einstein field equations, they assumed, along with Einstein, some stringent qualities on the distribution of matter and energy and on the universe itself. Yet cosmologists later realized that postulating slight differences in the density and distribution of matter and energy from the earliest stages of the universe was required. This is where Roger Penrose's and Stephen Hawking's study of black holes comes to the foreground. In 1965, Roger Penrose revealed in his singularity theorem a major truth about the underlying reality of our universe. Whatever models of the universe people would suggest from then on had to include singularities. Penrose showed that a singularity didn't require any special circumstances. In our universe, not only are singularities not impossible, they are inevitable. There has to be billions of singularities littering the cosmos. According to general theory of relativity, plus a couple of very general, easy-to-meet energy conditions, a gravitational collapse to infinite density would occur. In particular, black holes must contain singularities. During his research for his PhD, Stephen Hawking realized that Penrose's singularity theorem on black holes had implications for understanding the origin of the universe. He saw that black holes gave a picture of the Big Bang in reverse. The Big Bang's explosion occurred and space expanded outward from the singularity. In the black hole, space curved inward to the singularity. That meant that the mathematics Penrose used to describe black holes also could describe the universe as a whole. It was a key observation because it corroborated that the Big Bang really happened and time had a beginning. Later, Penrose and Hawking worked together on singularities. In their 1970 paper, they developed mathematical arguments for space-time singularity. Now these results are called the Penrose-Hawking Singularity Theorems. Their work made singularities central to every theory about the nature, history, and future of our universe. According to the article Singularity Theorems and Their Consequences by Jose M. Semovilla, the main conclusions of the singularity theorems are usually interpreted as providing evidence of the singular beginning of the universe and the singular final state of some stars. Senovilla's article is designed to clarify this usual interpretation. In 1973, Hawking, with George Ellis, continued to study cosmological singularities. These three physicists, Penrose, Hawking, and Ellis, produced a series of scientific publications that spelled out the implication of general theory of relativity for the origin of space and time. Experimentalists since have identified other singularities, including the one at the heart of the hypermassive black hole at the center of our own galaxy, discovered by Reinhold Genzel and Andrea Ghez, who shared the Nobel Prize in Physics with Penrose in 2020. Now, with these 7 scientific evidences, denoted by the acronym SURJET, supporting the truth of premise 2 of the Kalam argument, we can accept the conclusion of the Kalam argument, namely that the universe has a cause. Stephen Hawking, though not an advocate for theism, nevertheless had this to say: almost everyone now believes that the universe and time itself had a beginning at the Big Bang. Hawking goes on to say, the odds against a universe like ours emerging out of something like the Big Bang are enormous. I think there are clearly religious implications. Elsewhere, he says, it would be very difficult to explain why the universe would have begun in just this way, except as the act of a God who intended to create beings like us. Finally, he admits that many people do not like the idea that time had a beginning, probably because it smacks of divine intervention. These are stunning words from whom many consider to be the world's most prominent scientist since Einstein. The conclusion that the universe had a beginning is now virtually certain. and the evidence that it began by a Big Bang explosion is as strong as it can be. I will continue this discussion in the next episode.
Thank you for listening to Defending and Commending the Faith with Joe Mott, a production of Wave 94 Radio in Tallahassee, Florida. If you have any questions or comments for Joe, please forward them to Doug Apple at Wave94 at this email address, dougapple@wave94.com. And be sure to join us every Monday evening at 6:45 p.m. on Wave 94 and subscribe through your favorite podcast app. Defending and Commending the Faith with Joe Mott.